go. Okay, so the first thing that I thought we'd do this time is I'm going to go ahead, let's identify all of our foresights and backsights. So this will give us guidelines for where every instrument is basically working from. So now we know in between everything in between our orange lines are intermediate sights, same thing all the way down, and here's our last sighting right here. So now we can identify, we have station 2 and 3 are intermediate, 6 and 7 are intermediate, 10, 11, 12 are intermediate, okay? All right, so now we can go ahead. We've got our benchmark at 100. So I thought we'd probably just write down all of our elevations first at each station, or we can just, well, actually, you know what? Let's do station at a time. Why not, right? Okay, so first off, we want to take a first reading we always take when we set up to calibrate the height of our instrument is take a backsight reading under the backsight column at our known point of elevation. The known point of elevation is where we're at physically because we do not have an elevation yet for our instrument. So we're starting at our benchmark. We have to move up in this case to get to instrument height, which means whatever our backsight reading is, we will add that. So let's go ahead and look at the sightings that we have to do for this particular setup. Okay, so for number one, we know that, of course, our bottom line, the full line across our surveyor stick is the 1.6. So we know that we're in the 1.6 portion of our stick, and it looks like we're exactly 1 centimeter above that line. So we'll be 1.61. So I'll go 1.61. There's our reading for the number 1. Let's have a look at reading 2, 3, and 4. So here, the 3.5 line is just down here out of sight. And the 3.5, the 5 centimeter line is at the bottom of our big E or our big blocks. And then, so we have 3.55, and it looks like about 5 millimeters. So let's go 3.555 for our reading at station number, or reading number 2 at station A. Reading number 3 is 1.6 to the line, 1.61 to the underside of this black block, and about 6 mils up. So let's go 1.616, 1.616, or it could be 1.5, something very close to that. And then our last reading, number 4 at station C, we have 1.5 to our line. We know that where the big black, the wide black block starts is the 5 centimeter. So we've only completed 4 full centimeters. So we're probably at least 7 millimeters up from the 7 centimeter line. So it'll be 1.547. 1.547. Looks pretty reasonable to me. So starting at our benchmark, we're moving up to calibrate the height of our instrument. So at benchmark, our first reading is a plus because we're moving up, and it's 1.61. So let's go ahead and write down our height of instrument right away. Okay, so the height of instrument is the elevation of the station that we're using for a backsight, which is our benchmark at 100, plus the backsight reading we just took. So height of instrument will be 101.61. Excellent. Now we know that sighting number 2 and 3 are both intermediate sights. So under the intermediate foresight column, we'll go ahead and we'll mark down station A, and station B, and station C, since all of these are in this grouping of shots we're taking. So for A and B, we're going to go to intermediate foresight. Now that we've calibrated the height of our instrument, we are sitting up here at instrument height. That's where you need to think of yourself as being. So from instrument height, in both of these cases, in all 3 of these cases, from instrument height, we have to move down to get to these stations on the ground, which means all 3 of these readings we will subtract from where we're at, which is instrument height. So let's go ahead and we'll log these in to our foresight readings. So at A, we have reading number 2, which is a minus, because we're moving down from instrument height, a minus 3.555. Reading number 3 at station B is an intermediate sight as well, and that's below instrument height. We move down to get to it, which means we subtract that as well. So minus 1.616. The last sighting we take, our orange line, before we move, of course, this will be a foresight reading. So at C, we're going to take a foresight reading. From our instrument height, we still move down to get to that station. So we will subtract this reading as well, which is 1.547. Let's go ahead and do the math on these stations to get the actual elevation. So the instrument height is the same. Until we decide to move our instrument, we use the same instrument height. So let's go 101.61 for instrument height. I'm going to store that in my calculator to make it handy. Now I'll go ahead and start subtracting the readings that we've taken, knowing that which ones I add and which ones I subtract. All of these cases we subtract from our height of instrument. So I'll go ahead and minus 3.555. That will give me an elevation for station A of 98.055 meters. I'll recall my instrument height again and subtract my next reading of 1.616, which gives me an elevation for station B of 99.994. And then my last station, station C, which is a foresight reading, I will recall my instrument height again, 101.61, and I will subtract my 1.547, which gives me my last elevation of 100.063. Okay, fantastic. I pack up, I move to a new location. This one no longer exists. So my first reading I'm taking is going to be from a point of known elevation. So the known point of elevation we're using is C. The instrument has not been calibrated, so physically we are sitting at C at this point of elevation. We have to go up to get to instrument height. So from this known point of elevation, we have to move up in order to calculate our instrument height. So I'm going to go ahead and write down C. That is going to be our backsight reading, and then we have station D, E, and F. So I'll go C, D, E, and F. I'll write all the stations that we're shooting from this location. And now let's go ahead and get our readings here. So 7 and 8 weren't on this sheet, so I just added them. So reading number 5, we're 1.3 to this line. We're 1.34 to the top of this block, and maybe 1 more millimeter. So I'm thinking 1.341 for reading number 5. Reading number 6, this is inverted, which means that the station is above our instrument height. So this is going to be a 0.5 to the line, 0.5 and 4 centimeters it looks like. So let's go 0.54. Looks like it's pretty much bang on. We have reading number 7, which is 2.901. And then our next one will be reading 8. Of course, we don't have that as well, which is 2.745. Now, if we wanted to, we could go ahead at reading number 4. We could draw a line in between these, knowing that this is our turning point where we take a foresight and backsight reading, the end. And then just before 9, we have our next orange line, which is the end of the readings for this location. And then if we want, we can put an orange line there, just so these lines match what we have up here. Okay, so let's go ahead now that we have these. And we're going to be starting with calibrating the instrument height. And that, of course, is going to be done by taking a backsight reading at a known point of elevation, which is C. Because we start at that point of elevation, we move in the direction we're calibrating our instrument, or where the instrument height is, and that is above this station, which means we move up to get to instrument height. So we take the backsight reading, C, and we are going to add this to that known point of elevation that we're using, which is the elevation of C. So number 5, we'll write this reading down as a backsight, and we're going to add it because we're moving up to instrument height, and it is a 1.341. So plus 1.341. Then we have 2 intermediate sites at station D and station E. So let's go ahead and move over to our intermediate Foresight column. At station D, we have reading number 6. Now that we are actually, let's go ahead and calibrate our instrument height. As soon as we do our backsight reading, let's just get our instrument height written down so we know we are at instrument height. Okay, so we're going to take the known point of elevation that we're using, which is C, 100.063, and we will add the reading that we take on our stick, which is plus 1.341. That will give us the height of our instrument. And I'm going to go ahead and store that in location A. So I'm 101.404. Okay, and I know that I'm using the same instrument height for all of these stations, so I'll go ahead and do that. Now I'll move ahead to my Foresight column. Starting at station D, I have reading number 6. Now that I have my instrument height, I need to think of myself as being at this elevation for all of my readings. So my first reading, number 6, is the stick is inverted, which is telling me that the station we're reading is above instrument height. If it's above, the direction we travel to get there is up. If it's up, we add. So reading number 6, we will add that. It will be a plus 0.54. Station E, the station from instrument height is down. We travel down to get to it. So this will be a subtraction, and we will subtract reading number 7, which is 2.901. Our next station F, it's not showing on here because I don't have the picture, but it would be inverted as well, which means the station is above. So from instrument height, we have to travel up to get to station F, which means we add this reading, number 8. So it's a plus 2.7. Oh, I made one small error. This is not an intermediate site. This is the last sighting we take before we move. So we move to the Foresight column and then put our plus reading number 8, which is a 2.745. Okay, so now we've got everything from this next grouping of shots. So let's calculate some elevations. So we have the instrument height programmed in here. Our first station elevation will be a plus 0.54, which gives us an elevation of 101.944. We will recall our new instrument height again, and the next station is below, so it's a minus 2.901, which gives us a 98.503. We will recall our station once again, our instrument height. We will then, our last reading, which is a Foresight reading, at our yellow or at our orange marker, and it is above our instrument height, which means we travel up to get to it, which means we add that reading, which is 2.745 for a final elevation of 104.149. I'm going to go ahead and just keep that in my calculator because I'll be using that again. So here's my last station here, F, and it's now we move to our next location, and we're using station F. We're using this elevation to find our new instrument height. So now we have to use station F again. So let's write F down there, and then we have G, H, I, and J. G, H, I, and J. Now let's go ahead and we'll do our first station first, and then get our instrument height. So for F from a new location, we are physically starting at this location. That is our known elevation. We have to calibrate our instrument height, which means we start here, and the direction we move to get to instrument height, in this case, is down. So if we move down, that means the measurement we take, we subtract from that station to calculate instrument height. That station is 104.149, and we are moving down by reading number 9, which is a 2.1 to the line, 2.11, 2.12. I would say it's a 2.129. That's probably where that's sitting. So that is going to be a backsight reading at station F. And that'll be a minus, because we're moving down to get to instrument height, a minus 2.129. Now that we have that, let's go ahead and get our new height of instrument here. We will take the station that we were using, which was station F, elevation 104.149, and we will subtract this stick reading minus 2.129, and that gives us our new instrument height. And of course, I will store that in my calculator. So that is 102.02. Okay, let's go ahead and get the rest of our readings. So reading number 10, we have a 1.8 to the line here. I think it's going to be a 1.8, 0 centimeters, and probably 2 millimeters. Our next reading, number 11, is 1.0 to the line, 1.0123, 1.03 with no millimeters. Our 3.3 line is down here. We know that this is the 4 centimeter line and 5 millimeters. So 3.3, 4 centimeters, and 5 millimeters looks about right. And then our last reading, number 13, it is inverted. Now it's just below the 0.3 line, which means the space we're in is going to be 0.2. So we'll start by going 0.2, and then that is going to be 0.2. Well, this is the 9th centimeter here, so we're probably 0.29 and at least 9 millimeters. So I think 0.299 is probably pretty accurate for reading number 13. Okay, so let's go ahead and jump on. We have station G, H, and I are all intermediate sites. So let's write down what those are. Now we're physically at the elevation of our instrument. From there, the first station we move up, so we will add. The second station we move down, so we'll subtract. The third station we'll move down, we'll subtract again. The last station, which is a Foresight, we move up, so we'll add. Okay, so let's go ahead and get our readings here. So for station G, this is reading number 10, 1.802. For station H, it's reading number 11, which is 1.03. For station I, it's reading number 12, which is 3.345. And then our last reading, which is 13 at station J, is plus 0.299. Let's go ahead and finish off our elevations. So we have a 102.02 instrument height. We'll go ahead and our first reading at station G, we will add this. So plus 1.802, which gives us an elevation at station G of 103.822. I'll recall that instrument height again. The next one, we will subtract 1.03, which gives us an elevation for station H of 100.99. We will recall our instrument height once again, and we will be subtracting. So minus 3.345 gives us an elevation of station I of 98.675. And then our final station is station J. We will recall our instrument height of 102.02. And this time we will add our 0.299, which gives us our final elevation of 102.319. And there you have it, just like that.